everybody. So Catchoom is a technological provider. We provide the best-in-the-class visual recognition technology. And although Catchoom started just 6 months ago as a separate company, we are a spin-off of Telefonica Digital, that some of you may know is third in the world, largest in the world telecommunication company. So we have been working on this technology for the last more than 4 years. And one of the things that we observed was the need from the market to deploy our solution in the cloud, and also we are building our own software as a service solution. So today I would like to share with you our vision of what it means to run visual recognition in the cloud. But before I start, I just wanted to clarify what we exactly understand by visual recognition. So for us, it is identifying the object that is in front of the camera by comparing the image from this camera with a large collection of, with a large database of reference objects. And here you can see some objects that we recognize very well. But by seeing, I'm sure we've seen here at ARE many very impressive demonstrations of mobile tracking technology, and to a certain extent, this also have capability of identifying what the object is. So some of you may ask, why server-side visual recognition? And we think that they both will coexist together and complement each other. And the server-side visual recognition, we believe that has several very interesting properties. So for example, it's very easy to deploy on very different platforms, because if you are a developer in your app, you just need to send a photo to the service and then deal with the response. So you can deploy it very easily even with existing apps if you decide to add this visual recognition capability. Also, it is very easy to update the database of reference images without the users even noticing. And of course, there's practically no limit how many images you can have in your database, which on a mobile device, it's often a problem. And you might also think, you may be surprised how fast it is. So the round trip to send the image and recognize it and get the results back, if you are on 3G, pretty much always takes less than 5 seconds. And if you are on Wi-Fi or 4G, it's pretty much instantaneous. So this recognition, you can get back the results within less than 1 second. So let's say that we decided for the server-side recognition, and what can we do then with this technology? And let me use the example of our Catchoom core technology to give you a little bit of a picture of the situation. So we can already, in a very reliable way, recognize objects that have some characteristic pattern on it, and they don't need to be flat. So we are very good at recognizing non-flat objects, irrespectively of occlusions and lighting conditions. And also, our solution is very fast and scalable. So if we think about a typical processor that we can encounter in the cloud, which is technology that you would see probably on your devices in the year 2007. So if we take one of this processor, and if we take one core of this processor, if we deploy our solution to search through a small database, that would take roughly 200 milliseconds to recognize the object. But then every time we add 10,000 reference images, it increases the time only by 25 milliseconds. So this is a very scalable solution. And another very important feature of our solution is that we can very fast add images, and then instantly they are available for search, which this opens quite interesting application scenarios. So why cloud? What cloud can offer us for visual recognition? So first of all, cloud is very good at dynamically allocating resources, to allocate the minimum resources that we need to fulfill the requirements. And something that is very easy in cloud is to allocate these resources in a dynamic way. So typically you would develop your solution on resources that meet your minimum requirement, and then if you need more throughput, the demand for your services increase, then you can scale it out. And by this I mean add more instances of the same resources set. Cloud normally provide a lot of mechanisms to make your life easier and do this kind of things like load balancing, backing up, mechanisms to ensure security, etc. But also cloud has certain demands that we have to take into consideration when deploying our solutions. So specifically a public cloud has some limitations. So, for example, going from a small machine or relatively small machine to a bigger machine, which is normally scaling up, it's not that straightforward, especially if you want to do it in an automatic way. And if you, for example, want to move from a processor that is with certain specs to a processor core that is more powerful, very often that's impossible. And somehow it makes sense that this works in this way. Another thing common in a public cloud is that the resources are not fine-grained. So what you can use is only certain combinations of CPU and RAM. And if your solution fits with one of the combinations, you are lucky. And if not, then you have to pay a little bit more than probably you should to deploy your solution. And of course, we have to take into account that we are sharing resources with others. So we have to design the system around the performance fluctuations. But really, why do we need the cloud, the flexibility from the cloud? Something very important to realize is that depending on application scenarios, the bottlenecks are in different places of the visual search task. So it's very different if you have a service where you have 10,000 reference objects, or where you have 1 million reference objects. The bottlenecks will be in different places. Or it's very different if you have to search entire collection of 1 million images, or if you can just filter out and using, for example, geolocation information and narrow down the search to some subset of it. So as you can see, depending on the application, there's need for flexibility. And really to leverage this flexibility inside the cloud, our solution to this is to divide the recognition process in highly optimized independent modules that can be rapidly launched or stopped based on demand. So this permits us to scale out the components of the system that needs to be scaled out, and not all the components, which turns out to be pretty handy. So let me give you two examples how this works for us. So imagine that we are building some basic visual recognition system, and the service is ready. You have your press release coming out, and what you want to make sure is that when the press release happens, that your system survives your success. Okay? Or, for example, if you have a service that allows users to interact with TV shows by taking just pictures of the TV, you want to make sure that when this show happens, that your system survives this event. So in this case, here what we can see is that at the top of the hierarchy of our objects, we have two main modules. One is a feature extraction that takes the query image and extracts some characteristic parameters for this query, and then a second module, which is feature matching, that performs matching of these features, query features, with the features that were extracted for the reference objects. And the point that I'm trying to demonstrate here is that if your system, for example, has less than 10,000 images, then the feature extraction, in our case, would take roughly 200 milliseconds, but the feature matching would take just 25 milliseconds. So when you want to provide higher throughput, what you need to scale out is definitely the feature extraction. And when you continue to scale out, probably then there will be a need also to start to scale out the feature matching, but you would scale them out at different ratios with different proportions. And another important thing is that feature matching requires to store quite a lot of indexing information in RAM. And what is very important is that when you start new components, new instances with this particular module, you have to make sure that it can start very quickly. And this is something very crucial, that you can start and stop your components in the cloud very quickly based on the demand. And here we see another example where we show how to build a system that is able to search through very large collections of images. So what we do is we divide the matching part into different instances or different cores. They can be cores running on different instances or cores from the same machine or large instance, and basically each module, feature matching module, is responsible for searching through a subset of this large collection. And what the modularity gives us here is that if we would be building the system using a black box, we would need to repeat all the components of the visual search algorithm. But in our case, we just repeat the things that need to be we don't have to repeat the things that are common for all the different subsets of the reference images. And what is also interesting here is that we can dynamically select which subsets are searched. So, for example, if we have additional sources of information like geolocation, we can search only through subsets of the database. Also, we can imagine that this kind of architecture is very good if you have to co-host several visual recognition services in your system, because in this way, basically, knowing from where the query comes, you direct your query to certain parts of your system. And of course, like in the previous case, each component can scale dynamically very easily because the different modules can be launched very quickly. So to wrap it up, Catchoom has a very robust, fast visual recognition technology that is cloud friendly, and this means a lot of flexibility and seamless integration. And this was built, so if you are a developer or an integrator, this is built for you. So we welcome any suggestion and any question. Thank you. Yes?
How long does it take you to put in a new object into the database?
100 milliseconds. And it doesn't depend on the size of the collection that is already there. This is just to add the image into the system, to process the image and make it available. Yes.
Does the system allow you to handle multiple viewpoints of the same object?
Can you please repeat that question?
Yes, sorry. So the question was if the system allows to add multiple views of the same object. So we see this feature as a part of the application that you would build on top of our technology. So the way to deal with it is to add the views of the object into the system, and then when we return the best matches, then you basically deal with it, and this based on what we return, because we also return post transformation between the query and the reference images. So based on this information, you can basically progress further.
This is kind of maybe a combined question for both you and Tomasz. You know, we've seen a lot of folks that are aggregating these kind of silos of image recognition, databases, right, or image databases that can be parsed for recognition. Do you guys see any aggregation of this coming? Is there a need for that? Is there, other than Google goggles, right? Is there a need to get to a publicly available database that can be searched by multiple AR providers?
From an AR point of view, we're actually working together with them, and it's integrated into our Juneo browser to easily find information. So coming back to his statement, for the augmented reality pure play players, this visual recognition side of thing is a good way to find the first match to then do visual recognition directly on the device. So what we are doing is we're basically taking the first image from the live camera stream, we're sending it to our cloud-based server, but it runs their solution, and they return results which we then process on the device.
So you're doing, you're doing a hybrid thing where you're
exactly
you're doing the detailed stuff actually on the client.
exactly yeah
Cool.
exactly
Okay.
yeah.
So the way we see it is that well, the main difference between this and Google Goggles is that we are not attempting to search entire internet. So what we provide is the ability to search through a collection that you control. Okay, you control for your application.
Now you mentioned support for non-flat objects. How well do you work with non-rigid objects like toys, which can be sort of moved around?
So this strongly depends on how characteristic these objects are. So if they have enough, say, features or they are sufficiently characteristic, then we can whatever we can pick. For us, it's enough if we can just if we can provide just a small pieces of this object that is similar to what we have, to the image that we have in the database. So so if the object is very characteristic, then we are very robust towards this kind of deformations. But of course, if there is a very small logo and then the deformation happens exactly there and it cannot be recognized, then it works a little bit worse.
One last question. All right. Thank you very much.
Thank you.